Hello everyone. In our today's part, we will discuss about latent heat. That's our topic. Now, I want to start my discussion with a relevance to the previous lecture is that all of you remember that during melting or freezing or boiling, during these things were happening, that means any kind of change of phase happens at constant temperature. Right? But during this changing, do we stop giving the heat? Do we stop giving the heat? No. The heat is keep on supplied. There is no stoppage of applying the heat. Now the question that might cross your mind, that if you are keep on giving the heat but the temperature is remaining constant, then where this heat is going? Where is this heat is going? Means who is absorbing this heat? Clear? You're heating something but its temperature is not increasing. Now the answer is very simple. The heat goes the heat is used in changing the state of matter. That means one object was at solid state, due to your heating it converts to liquid state. Clear? So the heat is actually going in changing its state. But why is it required? It can be easily answered, it can be easily explained through the molecular models. Here we are going to explain latent heat using molecular models. So let's see, before we going to explain this amount of heat that goes for changing the state of matter, that heat is known as latent heat. So when you are heating the ice, it reaches 0 degrees centigrade, then you keep on heating it, the heat keeps on going until it becomes water. During that phase you keep on supplying the heat. That heat is called the latent heat of ice. Similarly, if you are going to heat the water and try to turn it into vapor, you keep it on heating after it reaches 100 degrees centigrade. Though there is no change in temperature, it happens at constant temperature, but the heat keeps on going, and the amount of heat taken by water to change its state from water to vapor, that heat is called the latent heat of vaporization of water, or the latent heat of boiling of water. So we will try to understand this latent heat now. Just giving you one example, you will understand the latent heat of melting. What happens in the process of melting? The ice converts to water. More basically, the solid is converted to liquid. Now we know in our first lecture that we explained that each and every substance, might be solid, liquid or in gaseous state, they have different phases, but one thing is common in all of them is that all of them are composed of huge number of molecules. Clear? Now let's think the melting. I hope all of you remember the melting is conversion from solid to liquid. Now what happens in a solid? In a solid, the molecules are all fixed at their places. Clear? Yes, the molecules are always fixed. They can't move in solid. They are fixed in their positions. Now inside a liquid, the molecules are no more bound, but they can move inside the liquid surface. Now the question appears that when the solid reaches 100 degrees, the 0 degree centigrade in ice state, and then we keep on heating it until it becomes water, what does this latent heat does? Now basically in the solid, the molecules are fixed at their positions. They have their own potential energy, for due to which they remain in their position of rest, and they of course a little bit vibrates, but they do not leave their positions. To make this conversion from the solid state of static positions to this motion of liquid state, this total internal energy is converted. Their internal energy is basically the latent heat energy is basically used in converting the solid state molecules into liquid state molecules. Means the latent heat goes to remove the molecules fixed at their positions to make them move inside the surface. That means the latent heat is basically used in making the change of state. It goes in change of the state of matter. So that is why we have to keep on heating the substance, though there is no change in temperature, but the change of states are occurring inside it. That is the importance of latent heat. That is the basic concept of latent heat. Now this thing is discussed at the end portion of your chapter. I discussed it earlier because you make your basics clear. Now what is this latent heat and how can we measure it? We introduce a new term. The specific latent heat. I hope all of you just remember, a good student will remember about the specific heat capacity. The specific latent heat is also very similar to it. Means what? It's like it actually refers to the amount of heat required to convert per unit mass of substance from one state to another. That amount of heat is called specific latent heat of that substance. Means unit mass of substance going from one state to another. That per unit mass substance is called its specific latent heat. Like what? Example, you take 1 gram of ice at 0 degree centigrade and you convert into a 0 degree centigrade water. 1 gram I mentioned because of the unit mass. So this 1 gram of ice will take some amount of heat to convert from this ice state, that is solid state, to water. So the amount of heat taken is the specific latent heat of that substance, that is the specific latent heat of ice. How do we measure it? Like total latent heat taken. Equals to Q. That is the total heat taken. Okay. Now, if I take mass to be M, small m, so the mass is small m, heat taken is Q. So if I ask you how much heat is taken by per unit mass, how will you answer? So Q by m. Q total heat taken, m is the mass. So if I divide Q by m, I will get how much heat taken per unit mass, and that thing will be called specific latent heat. The specific latent heat is expressed by L, and it is total heat divided by mass. And this is the mathematical expression of specific latent heat. This formula will be also used as cross multiplication m into L is Q. This will be very much used in case of latent heat numericals. Now there are different names for the latent heat of fusion of ice. Latent heat of fusion of the ice means that how much heat is taken by 1 grams of ice, or the water from 1 gram of water for changing its state. So the topic latent heat basically tells us about the nature of the substance. Any object whose latent heat is more, he will take more amount of heat to convert from one state to another. Whereas if one's latent heat is less, it will take less amount of heat to convert from one step to another. Clear? So this is the concept of latent heat, and this much we need to know about it. In the next video, we will try to learn about the numerical and the problems on this topic and how to solve them. But first, make your concepts clear, and yes, very importantly, remember these two formulas. Thank you everyone.